Hello everyone, welcome back to the channel. I'm going to start something new, and it's based on feedback from when I was doing the Telnet Mud project. The feedback is that a friend of mine was asking about what level of understanding of C# is needed to follow along with the Telnet Mud project. And based on that feedback, I felt that I should do a series about .NET development and C# in general, going through the kind of basics of what C# is and how to develop it, and how it's structured, and with things like classes and objects. So I've devised kind of a course that I'm going to be going through, and it's at the moment I've got at least 12 different lessons, and they range from the basics of setting up your development system to actually writing something in C#. I'll go through interfaces and data types and logic statements, if then else, loops, recursion. We'll do other things like arrays and lists and collections. We'll talk about interfaces and inheritance and the difference between an abstract class and a protected class. We'll talk about how to read from file, what's a stream in .NET. We'll go on to some of the more advanced features like generics and multi-threading. We'll look at the async, await keywords and what they give us. We'll also look at dependency injection and reflection. So that's the idea, is to help people kind of get up to speed with what C# is. So hopefully they can, you can engage more and be more excited about the Telnet Mud project. Okay, so to go on, what is C#? So C# is a development language that's quite mature now. Although it shares its name with things like C and C++, it's loosely based on those two development languages, not a direct descendant of C++. C was developed back in the 1970s, and C++ came out of that, was a direct descendant of C, whereas C# has more of its roots from Delphi. So Delphi was a language that was written by Borland, and the guy who which I can't pronounce his name, he left Borland and joined Microsoft, and from that he developed C# independently of C and C++. So that's kind of it's a language, it's a strongly typed language, it's a compiled language, meaning, and it's compiled to intermediate language called IL, which the .NET runtime executes. And the .NET runtime is built into the operating system. There are different versions that have been going on. We're up to .NET 5 now. That's been released, I believe it was November last year, November 2020. And the idea of it is it can now run anywhere. So you can get runtimes for Windows, obviously. You can get runtimes for Linux. You can also get runtimes for the Raspberry Pi. So this here is a Pi 3. This runs .NET. It'll also run the latest version, .NET 5, which is what .NET Core became. So in the beginning, a little bit about that. In the beginning, there was a .NET framework, and then over the time, other things were introduced, such as the Mono framework, which was an open source implementation of the .NET runtime to get it to run on things like Linux. And then there was a version of that to run on Android and iOS called Xamarin. And then it was getting a bit kind of fragmented and a bit nebulous, so Microsoft decided to say, okay, we're going to bring in a new runtime called .NET Core. And now with the latest release, .NET 5, this is called .NET 5 now, and that is .NET Core, what .NET Core has become. The other older frameworks can still be used and still be developed for. In fact, in some cases they need it depending on your target hardware. So the Pi 3 will run .NET Core. This is a Pi 0. This will not run .NET Core. It will only run .NET Framework via Mono. And I'll show that in a minute so you can see some of it running. Um, so yeah, so it's a bit the framework situation is getting a bit better, but there are still lots of platforms and lots of software that have been written in the older .NET framework, which will need to be updated to use .NET 5. And sometimes .NET 5 isn't necessarily code compatible with some of the previous versions. There are some changes, and obviously, if your software is relying on third-party libraries, and you change to .NET 5, then those third-party libraries will also need to change to .NET 5. .NET 5 can load up and use .NET Framework packages quite fine. We've got one of those in the Telnet Mud project. We have a warning on the compile that some may noticed about warning about the Dapper third, the Dapper library that I'm using. Okay, so in order to develop C#, what we need a development environment. Now there are a couple to choose from. I go with the Microsoft one. This is Visual Studio 2019. There is a completely free version that you can get from Microsoft called the Community Edition. That is the version that I'm using here. This is the one that I recommend. It's got everything built in, and it, for the whole part, just works. There's another one called Rider that's done by another company, the people who did Just Decompile, and I think it's JetBrains do that. That is not free. You have to pay for that. Microsoft also do a cut down. Well, it's not a cut down version one, but it's a different editor called VS Code. That is multi-platform. It can also compile C# and do C# projects. There are other utilities out there. One that I like is one called LinkPad, and LinkPad is quite nice because what it allows you to do is it allows you to quickly do experiments with I think it's got a capital L there. Yeah, capital L. It allows you to do experiments within C#. This is free, but if you want Code Complete, which would have helped me with the capital L there, you have to pay for that. But it is free to use out the box, and it will support .NET and .NET Core and everything, so that's fine. As I'm using Visual Studio 2019. Visual Studio 2019 has this idea of extensions and plugins, and what that allows you to do is to add things into the IDE. And some of those that I have installed that I would really recommend are things like Rosalinator. Now that is a free code analysis plugin. You may have heard of a platform, a third-party tool called ReSharper. It does the same goal as ReSharper, but it doesn't cost as much. In fact, it's free. And there are some problems with ReSharper I found with large solutions, and it runs out of memory and can slow stuff down. CodeMate is another thing I would recommend that does code cleanup. VS Color Output, that's quite nice. When you build, you get different colors in your build output. NUnit 3 test adapter allows us to run unit tests, which we will come to. I have a comment remover, which I always had to use for something else. And there, I haven't got it installed, but on my work machine, I also have a spell checker because my spelling is atrocious. And working with a team, I don't want to get my code reviews caught up on, hey, you misspelled this. So yeah. So what is .NET? .NET is a framework. As it's quickly described, it's a framework, and it allows you can build different kinds of programs for it, whether it's written in C# or VB.NET is another implementation of the .NET language as well. And we can do things like console applications, i.e. applications that you would normally run like in a DOS prompt. That's kind of a console application. This here is a console application. If I run this, you will see that it builds it, and then we have this. So this is Hello World. This comes out of the console, and this is just a console app. Windows services themselves are technically console applications, i.e. they don't have a user interface or a front end, so to speak. Another big thing that .NET is used for is web apps, and .NET Core and .NET Framework support ASP, .NET, and MVC, which is Model View Controller. They are web app and web development frameworks and platforms that you can use. We often see those tied in with front-end technologies such as Node.js, Angular, JavaScript, jQuery, Vue.js, all this kind of stuff. So when you start up a new project, so you install Visual Studio and you're like, right, I want to create something, which is great. You choose your console application. We need to talk about, first of all, how things are stored within .NET. So if we can imagine where our code is going to go, so here we have a program, and we see we have a class, we have a namespace, and we have a function here, and we also have this file name. And we also have this what's called an assembly. So app1 in itself is an assembly. An assembly is a group of code that's linked together. And .NET can load assemblies. It can link to assemblies at design time. So you can load in what's called a dependency. So we have some dependencies here. And we are dependent on the Microsoft.NET Core.app assembly here. We can also install other pieces of code via Microsoft's NuGet packages. Some people call it NuGet, I call it NuGet. I think that's more. And so we can see we have lots of these things available. Yeah, we can come on to that later. So if you can imagine your application is kind of like the planet Earth. That'll be your application. Each continent would represent an assembly. Each country would represent a file. Each town or city. So a city might be a namespace equivalent, a town might be a class within that namespace, and a function is kind of like your road of where you are. So that's kind of how these things kind of fit together. A namespace is exactly what I said. It's a namespace. It's just a name, but what it does is it allows you to group your code into similar areas of your software. And if you have two classes of the same name, you can separate them by using namespaces. Now that's kind of bad design, but sometimes that can't be helped. If you install a third-party piece of code and it uses a class name that something else uses, then you can differentiate those by using aliases. And we'll come back to aliases a little bit later, but it's to do with this using statement up here. This using statement basically says we're using this namespace system. And system comes from here. We can see it right here. That's where it is. So all of these namespaces are included within the framework. Great. Okay. So what is a class? A class is a template. It's like a blueprint. And we don't refer, while we're running code, we don't refer to classes. We don't run or execute classes. We instantiate classes into objects. So an object is a built class. So we can modify our program here to say, we'll create this. So what we can do here is we'll add, just briefly, another function on the class program called run. And we'll move this out here. So we're going to, and inside our main, now we'll come back to what static is, but every console application in this case needs an entry point. And the entry point is defined in the framework as static main, and that's what it looks for. The framework will open up your assembly, and it will go, oh, it's console app, okay, great, let's look for the static main function, and then if it finds it, it'll execute it. But if it can't find it, you'll have an error. So that's why we have this here. This is what's known as our entry point into our program. What we're going to say here is we're going to create an object of type program. Now we can go program equals new program. And that's what we're doing here. We're taking our class and we're building a new object called program of our class. And then we're going to call that run function. There are only functions in C#. There are in some other languages you have a differentiation between functions and subroutines and subs. In BASIC, for example, you can have functions and you can have subs. In Visual Basic, you can have a sub or you can have a function. A subroutine is essentially the same as a function, but it has no return. It doesn't return anything. A function is a subroutine that returns something. Now, normally what happens is it saves some data away on the stack, and the runtime will pick that up and give it back to whoever called the function. So in this case here, we are creating a new program. We're going to call the variable program, and we're going to then call the function run. And when we do that, we can see that we get our hello world. So that's great. We can also create another file. Now C#, no, we're good. Add class. And we're also going to call this program. But we'll call it program.run because that's where we actually want the name of the file. File name is here. Now, it's in the same namespace. It's called the same thing. But you'll go, but if we compile it, we'll get an error. And we can see we've got an error. And the error is the namespace already contains a definition for program. Now, in .NET, there is a bit of a shortcut. The way you can separate class implementation across several files, and you do that with the partial keyword. So that means that this class program and this class program, these two files, when they're compiled, they're combined by the compiler. So although they're syntactically separated by files, they will be built into the same thing. So what this allows us to do is it allows us to clean up our code. We can remove the implementation of run here, and we will say that this is public because we want to, we're going to call it. We'll come back to what public means, the difference between public, internal, and private and protected. We'll deal with all that a bit later. This is just to get us up and running. So again, right here, what we have is this is the entry point. So what we can do is we can put a comment in here. So a comment line, a single line comment in C# is denoted by the 2 /. So we'll say this is our entry point to our program. And then in this file here, what we can say is we can say implementation of our program. So so what we have done is we have separated out our implementation from our entry point. Again, we just have program. Now, C# also has a shortcut. Now the shortcut is the word var, and that basically says determine the type of this variable based on what it's set to. Now, in this case, we can see that program, yes, we know it's a program, but we can also see that we're creating a new program. So from right here, the type of program is pretty obvious from what it's being set to here. In some cases, if you have a badly named function, and you have something called var thing equals. Okay, so I might have a bit of a hiccup there with technical difficulties. That's fine. So where was I? Right. Okay. Yeah. So in that, talking about var, and in that case, the type that is returned from the function is not obvious. So in that case, var is a bad thing. It's about code, about clean code. It's about making this kind of stuff is about making code easy to be read by someone else, or could be you 6 months down the line. The number of times I've come to code that I've written 6 months earlier and going, what the heck was I doing? So it's good. These are good habits to get into right from the very beginning. So we have to recap, we have our implementation here, our program here, and when we run it, we should get the exact same result, which we do. Hello world. Okay. There's another. Okay, so yeah, deciding a little bit on where to go next. So we talked briefly about classes. We will come back in the next session, and we will talk about structs. We'll talk about structs in the next one. We'll also talk about creating we've done the console app, the Hello World console app. That is in programming. I think the first. It's kind of a running historical thing where the first program that anybody ever writes is a Hello World program. So what we'll do is on the next session we'll cover things about what's inside the class and how we deal with that. So yeah, any questions? Don't hesitate to ask. And thanks for joining us. See you next time.